Okay, good. So, hi guys. Hope you're doing good. My name is Ramzi. I actually presented the last time. I'm a network security engineer. I work mainly for Cisco products, Palo Alto, F5, Symantec, and I have my friend here. He's gonna present the lab with me. His name is Taimur Ahmad. I actually mixed his name. So Taimur, are you here? Can you like give us a brief about yourself?
Sure. Hi, my name is Taimur Ahmad. I hope you can hear me. Can you?
Yes. Let me fix
Oh,
that.
Same one. We can hear it.
yeah, please fix my name first.
Okay.
Okay. So, hi, my name is Taimur Ahmad. I am a network and security engineer at a Cisco Gold partner. I've been working on security for about 2.5 years now. I have my CCNA in RNS. I have a CCNA in security as well. I have, like you see on the screen, I've been working on Linux as well, and I have a CCNP in security. My concentration exam was in ISE. That is why you see me today helping out Ramsey. Okay.
Oh, okay. Thank you, man. So actually, I was working with Taimur a couple of days ago. He's very good on ice, and that's why he's here to present the lab for us today. Okay. So without further ado, let's start with this. Okay. So in today's presentation, I'm gonna start by talking about ice. What is ice? For those of you who have you hear that a lot about ice. It is a big product and whatsoever. So now is the chance for you to know what's ice, to get to know the features about ice, and then we're gonna like jump a little bit about AAA section in ISE. Second part is going to be ISE features. I'm going to tell you about all ISE features, not all, because actually it has a lot of features, but the main features, the advertised features. I'm going to be jumping to the deployment modes. We're going to be where I'm going to be talking about the personas, or let's say the modes where ISE can work in. Last thing for me would be AAA on ISE. I will be explaining like briefly what's AAA, what's the point of AAA, and how can we configure AAA, this whole phenomenon of AAA on ISE. Afterwards, we're going to jump to Taimur with the lab. He's going to show us a live demo about this. He's going to configure everything. He's going to be configuring the switch. He's going to show you ISE, and he's going to show you everything. And if we have time at the end, we can have questions. And of course, if we do not have time, we can move the question part to the group as we always do. So what's ISE, man? ISE is a very big product. ISE is a mixture of products. It's for me, it was very complex at first because it's like a new concept. You're like dealing with something that's not a firewall, that's not like a security entitled product. But spending some time on ISE, you're gonna love it. It is very big. As I said, it is complex at first, but you give it some time, you're gonna like it. It has a lot of security features, and it can show you, like, if I want to like brief ISE, I would say ISE is a network access manager. ISE can control everything about a network, especially in terms of end users. So in ISE, you can know who is accessing your network, when did he access your network, what is he using while accessing your network, from where did he access your network, and how, in what way. Okay, so mainly if you think about it, how can an endpoint or an employee or whatever access your network? There are three ways: either wired, using like plugging himself into a switch; wireless makes sense; and VPN. I think that's the only three ways you can access a network. And ISE can actually have visibility on all three, and can have like can restrict and can control every single detail about this endpoint that's connecting to my network. So that's a very big phenomenon. It's actually the future of network security, and it, like, Cisco has a lot of emphasis on this product. So I'm gonna be directly jumping into the features. Okay, there are a lot of features. I'll be talking about the main ones. First one is device administration. So as you know, guys, you've heard of TACACS. You always hear about Radius versus TACACS. But for me, like, Radius has its own like playground, and TACACS has its own playground. In terms of device administration, and for those who are not familiar with that word, device administration means I have a network devices in my environment, and I want to restrict who, the five questions that I did ask in the previous slide. So who, when, where, what, how. you can actually deploy this idea on network devices. So I can control who can access my network devices. We're talking about strict network devices, for example, switches, routers, these kinds of stuff. So I can control specifically what command can this user use or issue on the CLI, plus everything that the user is issuing. I will have a backup. I will not have, I will have it accounted. I can see what did this admin do on my network device and at the certain time that he did it. So that makes a lot of sense in terms of audit. And if something happened, you can go back and see who did what on what device. So it is a very good feature, and it relies on TACACS for that. Visibility, that's a big topic too. ISE provides visibility using the profiling sensor. So what's profiling? When someone connects to my network using ISE, I can know a lot about the device. I can know the vendor. I can know what version are you using in this device, what software are you using. I can know, for example, it can be like, for example, Cisco. There are a lot of Cisco products. I can know exactly what Cisco product. For example, I can. This is a 7900 telephony device. I can know a lot of stuff. And how does ISE know about this stuff? It actually uses probes. So what's a probe? It's actually something or a tool that ISE uses to identify the endpoint. I'll give you an example. So DHCP, DNS, HTTP, Radius, Nmap, SNMP, you're familiar with these guys. So for example, HTTP, or let's say DNS. From DNS, I can actually, since I have like the IP of the endpoint, I can, if I can like do a reverse lookup on this endpoint, I can from HTTP, you know that HTTP, DHCP actually has a lot of info that's providing ISE. So usually, if you want to like configure the HTTP, you're going to be configuring IP helper for on the network device, so that it will first try to get an IP from ISE. This will not work, of course, because ISE is not the DHCP server, but ISE can take a lot of information from the DHCP info provided by the endpoint, and then you can like have the secondary method, which is the real DHCP server. In addition, Radius, which is using like .1x, we're going to talk about it. Radius provides also a lot of information. You can have Nmap scans from ISE towards your endpoint to know like a lot about the device. So this providing service is not actually, it's not just actually like I want to know what's this device or want to know the version on this device. I can actually have policies based on this device. For example, I would use, for example, profiling. If I want to like, let's say I have a Cisco environment, everything's Cisco telephony, for example. If I actually profile a telephone that's not Cisco, I will be able automatically to stop that or block communication from that phone towards anything towards my network. Okay, so that's the main idea of profiling. You can have an idea what's this. An example, you can see a Cisco IP camera, Cisco IP phone. It can go very deep in knowing, but you need here, it's like a give and take situation. You can actually use all probes, but this will like generate like a heavy traffic in your network. So it depends on what you want. So for example, I want to know about the endpoint, this and that. I will be activating several probes to do that. It is not recommended to like activate everything. It's never done. But as I said, it depends on the customer need, and it depends on the policy. So if I want to, for example, if I want to block, as I said, the phone thing, that everything Cisco is okay, everything that's not Cisco, especially telephony, I want to block it, I will be allowing a certain probe, not everything. So you get the idea. You can work with it. Depend on the customer's need. Okay, that's the big one. That's the one that we're going to be like configuring today in ISE, which is, as I said at first, it's the network access manager. It is the authentication, authorization, and accounting server. So what does that mean? It means that just think about it in a traditional network. Now, in your networks, there is no ISE. There is no such solution. Anyone could have like his laptop connect to your like switch. If he took a certain VLAN, he can access your network without knowing anything about the device. Just the only requirement is to be there should be a device. Just plug it in, you have access to the network. Okay, you can say like I can block the switch. you can do all of these, but when we're talking about ISE, we're talking about the bigger picture, about the professional picture, about handling your network in a very professional way. So what does that mean? It means that after I like configure my switch to like go for the authentication process, because the switch by default does not do that. You need to configure the switch to tell the switch that every single port or every single endpoint connected to a port cannot access the network. And again, that's enforced by ISE, not the switch. The switch is just a slave. ISE is telling the switch what to do. Okay, but you need to have certain configuration on the switch in order to enable all of these. So I have an endpoint. I'm just plugging myself into the switch. Let's say I'm using .1x. I'll be talking about that later. I will be prompted for username and password. Otherwise it will not work. Otherwise, I cannot have access to the network, no matter what. Okay, so I will be prompted for username and password. Let's say I'm an employee, so I'll be actually I'll have my data in the Active Directory. Usually, that's how it's done. You can have multiple options. I will be putting my username and password. Afterwards, this switch will send this credentials to ISE. ISE will check with LDAP. LDAP will tell ISE that's okay, that's a user. And after that, I can push, for example, I can tell ISE to tell my switch, okay, this user can access the network. This user, I can push VLANs. This concept is like very big. When you see it, it's like it's great to see how things are working, because this is not how we used to work with networks. This is a new idea. So you're gonna see like ISE pushing VLANs to a certain port. You can push access list to a certain port, so you can actually control the user, not just like the VLAN or something. This user can have this VLAN, and this user can have other VLAN, and this user will have this access list. It's very deep what you can do with this. So again, it uses authentication to like know who is accessing my network. Everything is okay. I can also control authorization. I can control what can this user or endpoint do in my network. So that's the big like the heavy feature in ISE that I really like. Guest solution. So this one, if you've been to an airport, you're actually gonna like have a free Wi-Fi. But how is that done? So you go to the airport, you're gonna see like free Wi-Fi. You're gonna press on it. You're gonna be redirected to a page. So at this point, you have three options that you can configure on ISE. ISE can do all of this. Okay. So first of all, you can most of the airports, like you can need to acknowledge that you're, for example, you're 18 plus. You're not gonna use the internet for like this, like negative stuff. So you just acknowledge this, and then you have access to the internet. That's the first way. Second way, you've been to a restaurant before. There is Wi-Fi, but in order to get to Wi-Fi, maybe you need to sign in using Facebook. So that's another thing. You need, like, it's called self-registration. Maybe you need to enter your info. You need to enter your info. Maybe you need to like log into Facebook or something, but it's not like an steady thing that we do usually. And afterwards, I can get redirected to the internet. Third thing, if you've been into a Cisco, like office, doing training or whatever, I'm sure Kelvin is familiar with this. So usually guests going there, they're gonna like have Wi-Fi. A page is gonna open. This page is ISE actually. Actually, this page, this service is ISE. ISE is doing this. You're gonna enter your info. This info will be sent to ISE. There's a network admin, someone who's controlling ISE, working on ISE. He's gonna like check your info, make sure everything is fine, and afterwards he can then like send you an email with the password. He can give you like a 5-day. You can access your Cisco internet for 5 days, and afterwards you can like enter the credentials, and then you're in. So these are the three types of a guest solution using ISE. So as you can see, ISE, like, it has a lot of features. BYOD, that's actually getting more like more and more used in environments nowadays, where you can actually get your laptop, get your endpoint. For example, let's say you have a phone, tablet, whatever. You can bring it into work after like certain checks that ISE will push on you. You can actually then access your internal resources. You can access the service. But this is, you can think of it being on device. You can think of it as a guest, but actually there is an addition to it, which is posture. I'm going to talk about it later, but let me tell you quick what's posture. So I'm a user. Let's say I have a laptop. I'm an employee in a certain company. I will go there. I want to use my laptop to access my internal resources in the network, so the corporate's internal resources. But you should agree with me that that's risky, because let's say I have like a malware or something, a network worm or whatever on my laptop. If I like have a free access to the network, to the corporate's network, I might like have I can like ruin everything. I might have this worm spread throughout the network. So what ISE does is this: ISE will let you have access to the corporate's resources using your own device, but there are certain criteria you need to meet, which is posture. So what's that? So for example, I'm accessing the network. If I'm going to give you an example. What's posture? So I'm accessing the network. First of all, if I don't have antivirus, you're automatically out. You cannot access the network no matter what. In addition, let's say I want all my employees, if they want to have their devices in my network, I want them to have the latest Windows patch, the latest Macintosh patch, whatever. I can either check like the firewall status on the endpoint, and if everything is okay, I'm like sure that this device is okay, is green, he can access my network, and afterwards they can access my network. The same concept goes to endpoints or phones, but yeah. So the same concept goes. Is there someone? Okay. The same concept goes with phones, but ISE cannot do posture on phones. There's something called MDM. MDM is actually the same as ISE like does posture on endpoints. MDM can do that on phones or tablets. But MDM is a solution that needs to be integrated with ISE in order to work. Okay, it's not like ISE does not have an MDM solution. Okay, but it can, as I said, it can do everything on an endpoint if it is like a laptop or computer. Okay, so that's bring your own device. Posture. I was like talking about posture. Posture is actually a very big feature that I really like. Posture is me telling the users, any user who wants to access my network, that if you do not comply with every rule that I enforce on you, you cannot access my network. And you'd be surprised about the things that ISE can do in terms of posture. I remember I actually did a project to a in a customer's premise, where he actually required that if a user, listen, he has six like conditions. First of all, that the firewall should be on. Second thing in posture is that the endpoint should have this antivirus, let's say Symantec, for example, with this build. It should be this build exactly, or it will not work. The user should also have the latest Windows patch plus Windows 10. It should be strictly Windows 10 plus the latest patch. Otherwise, it will not work again. And he requested that there is a service inside Windows, like is there something that you can change in the services? So the point is, ISE can go deep down in your like checking your endpoint to make sure that you are compliant. If any of these conditions is not there, or is not like checked, you cannot access the network. Plus, there is something else to it. You can have something called remediation. For example, let's say okay, let's talk about the antivirus. So I have this antivirus, but I do not have the latest patch. So what's remediation? Remediation is actually ISE letting me giving me the file, like the latest patch, to install on my device, and afterwards I can then try to rejoin the network. ISE will do the posture check again, and it can like tell you if you can access the device or not. So that's a big thing in terms of ISE. pxGrid. This is the hottest topic in ISE, because this is ISE talking with everything else. This is ISE sharing info. This is ISE getting info from an eco partner, let's say WSA, ESA. So FMC, usually they like you integrate it with the firewall. So what's pxGrid? pxGrid is actually it's just an integration with ISE that can help ISE, okay, to like do like like have better insights about the device. So for example, ISE can do a lot of things, but ISE cannot know that this user, let's say, has a certain virus. Okay. AMP on the other side can know that. AMP can like tell you if there is a certain like indication of compromise. So when I integrate AMP with ISE, what's gonna happen is this: ISE is gonna keep like giving traffic back and forth with AMP. So when AMP sees that there is something wrong or there is an indication of compromise, AMP will send a message via pxGrid. It's actually based on APIs to ISE, and ISE will take action. What is this action? ISE will actually trigger something called change of authorization, which means, let's say I'm an endpoint connected to a switch. ISE will redo my evaluation of me as an endpoint and can place me in quarantine, can place me like set a certain VLAN to me that I cannot access anything, or for example, only access the internet. I can do that on ISE. Okay, so that's actually pxGrid. It's just sharing information, sharing insights between devices, so that, and by the way, it can go vice versa. ISE can give info to the eco partner, and eco partner can give info to ISE, and they both can do actions based on what they receive. Okay. Threat-centric NAC, that's actually similar to pxGrid, but that's mainly focused on CVSS, which is like a score that an external device. So this is, to repeat this again, this is not something that ISE can do by itself. ISE need to be integrated by a third-party software. Let's say it's here, they're giving an example, Rapid7 or something. What that does is that ISE will trigger. So let's follow the flow. ISE will trigger scans. These scans will be sent to this third-party software. Okay, this third-party software, you can think of it as a sandbox. For example, it will like run checks, scans, it will make sure everything is fine, and then it's gonna return with a number, which is CVSS number. The higher the number, the higher the like, if you say quarantine, the higher the number, the higher the risk. So if, for example, ISE gets back from Rapid7 a CVSS with 10, this means that this is 100% vulnerable. I can quarantine this endpoint. So this is, in a nutshell, what threat-centric NAC is all about. Group-based policy segmentation. So now what you guys know, you're familiar with VLANs, you're familiar with access lists, you're familiar with these kinds of stuff, but it's actually like, if you want to say, let's say you have a lot of switches, and so you need to configure this on everything, and it's like pain itself. So this concept is a new concept. This is ISE. This concept is not like created by ISE, but it is heavily reliant on ISE. The process of TrustSec. TrustSec does two things in brief. First thing is called MACsec. MACsec is actually layer 2 encryption. So you can have like two switches connected to each other. It's a layer 2 connection, of course. You can actually have this encrypted, the traffic encrypted. Second thing is the security group tags. You've heard of it. Security group tags is changing the concept of a VLAN, but it is focusing on groups. So for example, instead of building a VLAN or creating a VLAN for employees, I can actually create a group for employees. I can call it employees, and the user, he can like plug himself to any port. If 802.1x, as we said, is working and everything is working, he can plug himself to the switch on any port. Based on his credentials, I will be like mentioning him in a certain group tag, or like putting him in a certain group tag. And after that, I can then push this configuration to the switch. Did you see the difference in concept? So it is not a VLAN, it's actually a security group tag. A user is put in a certain group, and this group can follow him whenever he goes. It's not port reliant, it's not VLAN reliant, it's user reliant. So wherever I go, I'm a user, I'll still have the same type of access wherever I plug myself, wherever I plug myself. So in brief, these are the features of ISE. The main features, as I said, ISE can work as a CA server, for example. There are a lot of things. ISE can work as a troubleshooting tool. There are a lot of things that ISE can do, but the big ones are these: device administration, TACACS. guest access, we've talked about it, identity-based services, bring your own device, segmentation, pxGrid, compliance and posture, and remediation, of course, threat-centric NAC, and DNA. DNA is actually, DNA is like, for me, DNA is useless without ISE. ISE is a very, very important element in DNA. DNA is a new thing to us. I've like worked with it like in a lab, nothing more than this. Everything will be software defined from now on. The concept of networking will be changing, guys, and like we need to be changing with it because this is a requirement for us to stay in the networking field. ISE architecture. So ISE can work in multiple ways. Okay, so if you're doing a lab, small lab, I would like say that you can have all the features of ISE working. So I don't want you like to get confused. Features, we talked about features. Now we're gonna talk about like the modes that ISE can work with. So there are 4 modes. The first mode is called PSN, which is the policy service node. This node is where the endpoint is communicating. This point is where me as an endpoint, I'm issuing a .1x communication, like authentication session. I'll be doing it with PSN. It is like directly involved with the endpoint, and it's also the radius or TACAX server, the thing that I told you about, and it is the place where ISE can push the decision or can push the authentication authorization process to the network device. As I said, you can install ISE to have the 4 things working together, or you can have ISE only working as a PSN. You can have ISE only working as a PAN, which is the administration. This is the administration where you as a network admin access ISE and do the configuration. After you do the configuration, it will be pushed from the PAN to the PSN. That's the logic of it. There is the MNT, which is the monitoring and troubleshooting node. So when you like it also reports, let's say, to the PAN, because everything, let's say the PSN is giving insights to the MNT, is giving that this user connected, this user failed, details. After that, if you want to like access these logs, you can do it from PAN. So PAN will be like taking the monitor, the troubleshooting and the logs, and you can view them from the PAN. And finally, the pxGrid. pxGrid, usually they do not like use ISE just for pxGrid. It is used with another node, but in general, that's the concept of nodes. As I said, you can have ISE purely doing PSN, ISE purely doing PAN, ISE purely doing MNT, and ISE purely doing pxGrid. There are a lot of like documents about how can you implement ISE. Depends on the users. A lot of things we're not gonna like go in this now, but I want you guys to know the difference between these 4 nodes or personas, as ISE states it. So as the title advertised, we're going to be talking about AAA briefly. Okay, so AAA is actually authentication, authorization, and accounting. As I said, by default, I'm a user. I like plug myself to the switch. I'm gonna have the traditional networking flow. There is nothing related to authentication, user passwords, nothing. Okay, AAA introduces these security concepts where I as a user need to authenticate before I can access the network. Okay, in order to proceed with this, I want you guys to be familiar with the naming. So a supplicant means the endpoint, okay, or the module that's like initialization. It's not going. Initializing this 802.1x process. Okay, it's called the supplicant. There are 2 types: the native supplicant, which is by default on Windows. I can show you guys. I think Taimur can show you this. The native supplicant, and there is any connect module that can do this. That can take the place of this supplicant. Okay, the authenticator is any device any network device that's going to be like the midpoint between the server and the supplicant. It's actually most of the time it's a switch, WLC, access points, these kinds of stuff, and the authentication server, which is ISE. Okay, so this process, in order for me, I want to like tell you something about this. If you configure the switch to do 802.1x on all the ports, okay, there's nothing that any user can do to access the network, because by default, once 802.1x is configured on a port, only 3 protocols will be like exchanged. STP, spanning tree, can pass. CDP can pass, and EAP. Okay, we're gonna talk about this now. So in order for you like to let's build on this. So there's a protocol called EAP over LAN. EAP over LAN is an encapsulation used to encapsulate EAP packets to be transmitted from the supplicant to the authenticator. So between the endpoint and the switch, it uses a protocol called EAP over LAN. Over LAN means should be like the same. It's a layer 2. That's the complete naming process. So and the EAP itself is actually authentication protocol used between the supplicant and the server to transmit authentication info. Okay. Finally, Radius is the AAA protocol. So Radius lies under AAA, same as TACAX lies under AAA, same and something called Diameter also lies under AAA. EAP lies under Radius. So now you can see like this hierarchy, how is it going. So Radius is a AAA protocol used for communication between authenticator and authentication server. This is like a brief let's talk this in a story manner, how everything happens. First of all, the session initiation. The session can be initiated either by the authenticator with an EAP request identity message or by the supplicant with an EAP over LAN start message. Before the supplicant is authenticated and the session authorized, only EAP OL, as I said, CDP and STP are allowed. Afterwards, we're going to jump to the authentication part. The authenticator extracts the EAP message from the EAP over LAN frame and sends a Radius access request to the authentication server, adding the EAP information in the AV pair of the Radius request. The authenticator and the supplicant will use EAP to agree on the authentication method. So I'm sure you've heard a lot about like EAP, EAP TLS, EAP TTLS, EAP, PEEP, LEAP. So what is this all about? There is like the mainframe and there is the inner method. Okay. So if I like, I'm using, I need to show you this. I want to show you this. I want to show you this. We're not going to go deeply in this, but I need to show you this. Like just take an idea, because there is the main method and there is the inner method. So by default, this tab does not show on your computers. You need to allow that in the services. Okay. So this is the main method. If you can see Windows native supplicant, which is this one exactly, supports these PEEP, EAP SIM, EAP TTLS, EAP AKA, whatever. So this is the main method. If you want to like jump to the inner method, you can see here the inner method. For example, Windows supports EAP MSCHAP version 2. So what are these all about? Guys, you need like don't get yourself confused with these. Actually, each one has its own uses, has its own way of communication. Some of them are like encrypted in a certain way. Some of them are strictly for wireless. Some of them are like using certificates. For example, the big two would be EAP TLS and EAP and PEEP using MSCHAP v2. PEEP using MSCHAP v2, which is the default on Windows. In Windows native supplicant, this is actually requiring a username and a password. That's it. You need to enter username and password that will be sent to ISE, will be checked on an LDAP, and then everything can go this way. The big other one, which is EAP TLS. EAP TLS is mainly using certificates to authenticate. It's and there is like an advancement on this, which is EAP TTLS, which is like builds the tunnel. It is actually faster. It is like user friendly, because I don't want like each time the user like to enter his username and password. It's better for the user experience. So I'll be creating a certificate, and the user will be authenticating using his certificate in the background. Okay, so this is like in general what happens. Okay, so there's the session authorization. I'm here at number 3. So if the authentication server can authenticate the supplicant, it will send a Radius accept. Accept means everything is fine. You have access to the authenticator that includes additional authorization information, the one that I told you about, such as the VLAN, downloadable access list, and so on. Okay, the authenticator will send an EAP success message to the supplicant, and the supplicant can start sending traffic after this. Final point, which is the accounting, which means I'm sure you've heard of accounting. Accounting is session accounting is this represents the exchange of accounting Radius packets between the authentication server. So in general, that's how everything is going on. You don't need like to know everything about EAP and so, but you need to know that EAP has a lot of like flavors. You can use each one in certain condition asked by a customer, whatever. And that's just a protocol for authentication and authorization. It's a AAA. Without that, we cannot talk about like making sure that the user is authenticated in my network. Okay. So now is the lab time. I want to just Taimur, are you here? Are you with me here?
Yeah, man, right here.
Oh, okay, great. So now I'm gonna like give it to Taimur. Taimur is gonna like show us about the AAA on ISE, how to configure the endpoint, the switch, which is the authenticator, and the authentication server, which is ISE. You can take it from here, Taimur. You can share your
Okay.
screen.
Okay, I'll share my screen in a moment. But
Go.
before I do that, uh, Ramsey, you were continuously saying that you will keep it brief, but mashallah, you went quite in depth, right?
Man, it's like we're yeah, I don't know, man. I'm just talking about the things that I think are important. And yeah, let's go. Show us, Taimur, how can we do this?
Okay, so do tell me when you can see my screen.
We can see your screen.
Perfect. Acha, before I jump onto the ICE and before I start doing the practical and everything, there are a couple of things that needs to be done before you jump into the configuration of ICE. The first and foremost thing that you need to do is you need to add a DNS record of the ICE. Let me show you my DNS as well. Because if you do not have a DNS record in the ICE, it will cost you dearly, dearly, not right now, maybe a week later, maybe a month later. But if you do not have a DNS record of your ICE server on your DNS server, you are bound to fail. The dashboard you are seeing in front of me right now, that is only visible because the ICE can resolve itself using the DNS that is mentioned on it. Okay. So when I was bringing up the ICE, there were a couple of things that I've configured. The first and foremost thing was the IP address of the ICE, the subnet mask, the gateway, the NTP server, the DNS server, and the domain name. The domain that I've been using to set up in my lab, that is called work-bench.com. First of all, I'd like to apologize if this belongs to anyone, but by the time I was setting up this lab, this domain was empty, and I just picked it up. Okay, so this, my friends, is a blank ICE. There is absolutely nothing configured on it. Just let me show you the running config as well. There are two specific portions in ICE. There's a CLI portion and the application portion. Whatever you see on the CLI and the show running configuration, that is not your application. The application runs behind the Lena that's firewall calls it. Let me show it to you. See, I have configured a name server. This is my DNS server. I have configured a default gateway, an NTP server, and a clock time zone. It says Karachi because currently I am in Karachi. And yeah, here it is, the domain name. Domain name is basically the domain, the website or the company that I'm currently operating or working on. And this would be your host name, the ICE. Generally, when you add a domain name, this mistake I've seen a lot of times more than I can count. The DNS record that you need to add onto your DNS server should be your host name dot your domain name. This is how it should look like. This is how it should look like. Your host name dot your domain name. This should be your CN name of the certificate, and this should be your host name of the machine as well. So enough talking. Let's jump onto it. Achha. In this demonstration, I will not be using an internal identity store because companies or organizations, they do not like creating a username password separately on every entity. So for that, they have a central repository or a central database or any central database or table, whatever you call it. They have a central point of view where they can configure, remove, delete, add, edit anything at all to the user groups. And that is your external identity source. You can use your internal identity source as well. In that way, you will need to create your username and password of each individual users on the ISE. I will not be doing that. Okay, so in this demonstration, I will be joining my ISE to the AD server. AD server means the Active Directory server. Active Directory is a Windows solution of your collective database of your users in which you can push group policies to users, whatever you want them. So this would be my join point name, AD join. My Active Directory domain would be work-nch.com, and I will submit that. And this is how I created a join point. This is a join point, and to join an Active Directory to the ISE, you will need to use a shadow user. Now, what is a shadow user? A shadow user is any user that can send a query to your central repository or database to fetch the number and the name of the groups that are present. Okay, so I do not have a shadow user, so I will be using the administrator account. Let me ATOR. I will be putting the password as well, and bam, this should work. Perfect, perfect. So this says operational. That means I have joined my ISE machine to my AD server that is connected. And when it says operational, it doesn't mean that it is just connected. It means that in the Active Directory server, I have now a machine called ice.workbench.com. So this is just the uh, join point. Now, after I have joined the ISE to the AD, now the next thing I will need to do is to import groups, not users, to import groups from the Active Directory that I need to authenticate and to push policies on. Now, I do not have any groups on the AD, so I will be showing you how to create groups as well. Ramsey, do tell me if I'm going too fast now.
No, you're doing great, man.
Okay.
Perfect speed.
Perfect. So I'm gonna add a group, whatever you call it. Let's say it is called Demo Lab. This is a group that I have added. Yeah, makes sense. Dump, dump. Why not? Okay. 1 second. Let's add it again. New group. Sorry. Yeah, this would be my demo-lab. So I've added a group demo-lab. Now I will be going to the ISE and I will import this group. I will go to group options, select group from directory, and I will use star here to retrieve all the groups. Now this is retrieving, this is not importing. Now this will be somewhere here, demo dash filter, demo, retrieve groups again. Users, now this is quite frustrating because it was working when I was testing it.
You can do this, Taimur. You can press Control F. Press Control F now, and Control F, and do type demo. Just do that.
Yeah, I did Control F. It is not doing anything.
Are you sure? This is...
Yeah.
Okay.
Either way, if it doesn't show up, I'll just add this group. It's a global group. And save. But either way, this is where it should show up. If it's not showing up, then I will need to troubleshoot it later maybe, but it is supposed to show it up in here. Maybe I've added a new group or maybe something like that, but it is supposed to. It is supposed to be here. Surprisingly, it is not. Either way, I have imported this group, and this is the group that I will be applying the policy on. Now I will go to the policy sets. Sorry. Now what I need to do is I need to add a network device on it. Network device is basically the switch that will connect to the ISE, or that will send authentication request to the ISE, the NAD that Ramsey was showing you. Here is one that I've already added. All you need to do is put a name on it. That's it. Put an IP address on it. This three portions, the location, the device type, these are optional. And the important thing that you need to do is you need to click on this radius button right here, and you need to share a secret. Now the shared secret is the one that is exchanged between the ISE and the NAT server before start communicating. Let me show you the configuration on the switch as well. Here it is. Here I have defined the radius server. I've put in the address IPv4, authentication port 1812, accounting port 1813, and the key. The switches use the term word key, and the ICE use the term word shared secret. It's the same thing. Now, once you have done this, once you have put the username, the shared key here, and once you have added the switch here, the absolutely first thing that you need to do is, before jumping on putting the users on the switch, the first thing that you should do is test AAA. That 80% of people do not do. I'm gonna put my user here, help desk underscore infra. I'm gonna put his password, 151. Now see, the user was authenticated, meaning if the user is going to connect the switch using this username and this password, is going to be successfully authenticated. Now I'm going to create a policy set. Yes, I'm going to ignore this. Achha. By default, the rule of thumb is never ever, absolutely ever use the default one. Let the default one be empty. I'm going to name this .1x policy demo. The conditions that I'm going to put here are device. There's a device. Location. The device location would be my lab. Let's create one more. The device type. Yeah, the device type should be a switch, and use it. Now I've created a specific policy set. This policy set says that, one second, this policy set says that if the authentication request coming from a switch that is device type equals switch and the device location is lab, then use this policy set. Either, if not, go down. Now I've uses the allowed protocols to default network access. In the end, I'll show you what that is as well. Now, authentication policy. Before I use this authentication policy, these are a couple of options you can use. Internal endpoints, internal users, AD join, absolutely anything. But in this case, I will be using my AD join point. The AD join point is the one that I had created when I was joining my ISE to my Active Directory. Now there are a couple more options. If the authentication fails, rejected. If the user is not found, rejected. If the process fails, rejected. Either way, I only wanted to proceed if the user is found and only if the user is authenticated. Now initially the authorization policy is deny access, but for the demo purpose only, I'm going to put it permit access and I'm going to save it. It saved successfully, looks good. Now let's jump on to the VNC of the user. Now, Ramzi, you can see the VNC, right?
Yes.
Perfect. So this is the VNC of the user. This is a normal Windows 10 workstation. I have disabled the LAN and I'm going to enable it. Perfect. It's working already. So in authentication, the first thing I'm going to do is enable .1x. In the networking, local properties, authentication. I've enabled .1x. I've used PEEP and I go into setting. I'm not going to validate the server because my workstation does not have the certificate of ISE. Instead, I'm going to use mschap v2. I'm not going to use my Windows login name because the workstation, the Windows 7 workstation, that is not joined to the domain. I'm going to do OK here. We're going to go in the additional settings. Now, there are a couple of things you can do. If your workstation is also joined to the domain, your computer name would be saved in your workstation as well. If it is not, it's better to do simple user authentication. Now I'm going to do user authentication. I'm going to put my username and password right here. HELPPSK underscore VUNDLE 321 @123. And this should be it. Okay. Now it's going to do identify. Yeah. Let's see. Let's go back to the switch. Yeah, there is it. Show authentication session. Yep. There is one Mr. right here who's on connected on Ethernet/1. Show authentication session interface Ethernet 0/0/1. And here you go. Voila. Now the user here is connected. This is the MAC address of the user. The MAC address looks fishy. That is because it is a virtual workstation. This is the username the brother came in with. And I've configured this host mode as a multi-host. Let me show you the interface config as well. And then 0/1. Okay, now this is the authentication configuration that you need to configure on your interface. But before that, you need to enable .1x globally as well. And this is the command of it. The first thing, the absolute first thing that you need to do is enable .1x globally on the switch so that the service is enabled. After that, you need to configure your switch port. This is your simple configuration on the switch port. The main thing that you need to do is, let me do .1x, this command right here. This enables .1x on the port. After that, you can go ahead and play with whatever you want. You can set the timers. I've set the timers as well. I've set really huge timers on it because the system was going on sleep and I had to enable it again. So I've put a really big timer, white timers right here, and this priority. So when we talk about priority now, priority is what comes first. You can use MAB as well, MAC authentication bypass. You can use WebAuth. You can use lots of stuff, but it all depends on what the priority is and what the order is. If the order and priority are two different things. Order is check this one first, then this one, then this one, then this one. But priority is out of everything that you have checked, use this one. Now I will let me show you the running config of AAA as well. We can, this is the AAA configuration as well. These are just 5 commands that you need to run on it. Nothing fancy in this. Authentication, authorization, accounting. The exact same thing that Ramsey has been talking, the AAA, the who, what, where, when, and why, the 5 questions that he asked. Let's see if the person that we connect is still connected. By the looks of it, yeah, he is connected. Now, this is the profiling that Ramsey was talking about. When the user is connected, by default, the ISE does the profiling of the device on basis of its MAC address, on different probes it uses, and then it uses its internal tables to select a profile or to select or to uh, make a suggestion or to conclude on what really the device is. So here, right here, this ISE has worked out that I am using a Microsoft workstation. This is the default authentication policy. It is using LAN switch V that I've added. It is on connected on Ethernet 1. ISE server is 1. Posture is not showing because I've not enabled posture, and MDM, again, not enabled MDM. But even if MDM was enabled, this is not a mobile, this is not an Android, this is a workstation. So an MDM is not really possible. In this scenario, posture would be the positive thing to do. Now, before we conclude this, let me just show you something. Now, this is what I've just figured out, that although the PC is connected, but it is still not able to get an IP address. And that is because the switch is using VLAN 25. So IP interface brief. The VLAN available on switch, that is 25, but the MAC address or the default configuration of the port, that is of VLAN 26. Now, when Ramsey was talking about authorization, that you can push things from ISE to your switch to automate things, that is what we're going to do now. This is VLAN 26, and this is VLAN 26 because Ethernet 0/1, here VLAN 26 is defined. But now we're going to push extra parameters, or like the exact word that Ramsey used was AV pair. We're going to use a AV pair to push different VLAN on this. Now we'll go back to, first we need to go back to results. We need to create an authorization profile. Here you'll see an authorization profile. Deny, permit. These are two demos. There are two, I think, default profile that you cannot change. I will create a new profile, say demo profile. Now I will not be using a service template. Access type would be access accept. I do not want to reject it. Now I'm going to assign a VLAN. Let me just double check what the VLAN was. Show IP interface brief, VLAN 25. Okay, so I'm going to put here VLAN 25. I don't think I need to put anything else. No, looks good. So I'm going to scroll down, and these are the attributes I'm going to push. Okay, so I have now created, where is it, demo profile. Now this is the demo profile that I will be pushing. Let's go back here, authorization policy. Now, like I said, never use the default authorization rule demo, open it up, open it up. Now the AD join the external groups. This is what I was talking about. Here I'm going to use the groups that I have imported from the AD. Now, if you have imported multiple groups, you can put them on multiple VLANs and you can just play around with it, completely up to you. Now, this is the security group tag that Ramsey was talking about. Now, in addition to what he was saying, let me just extend that security group tag. Here you can place an external tag on an external parameter on basis of which you can make decisions later. For example, if the one condition here, I do not want to use this one condition. I need to, let's say, I need to see if the device is a compliant device, if it is using EAP MS chat as well, and what else? If it is using, open up, if a device, now if the device location is this, now there are lots and lots of things that you can do, all location, yeah. Now I have used 4 different criteria. Now instead of checking 4 different criteria each and every point and then on the network, I can just select that tag that I use, maybe contractor developers, let's say just developers. I can use this developer tags all over my network to apply the policies. I do not need to use these 4 tags or these 4 conditions or scenarios. Let's just use this. Demo profile, developers looks good. Okay, let's go to the workstation again. Let's ask him to bounce his port right now. Let's bring this brother up. And let's see. Aha. Now this is what I was talking about. Let me show you from the switch as well. And there you have it. An external parameter that was pushed from the ISE to the switch. Now this is just a single VLAN. You can do all kinds of stuff in it. You can push downloadable ACL, you can push web redirection. Let me show you what else you can push. Here is the authorization profile. Let's just edit this one. Now here are the common tasks that you can use. You can push a downloadable ACL, you can use an ACL. Now the difference between an ACL filter ID and a downloadable ACL is that the ACL filter ID exists on the switch. However, the downloadable ACL exists on the ISE and is pushed from the ISE to the switch. Now, downloadable ACL is an enhanced version of what you can say the ACL, but the only difference is that if you already have ACLs, if you have about 25 lines, 26 lines long ACLs on the ISE, on the switch, sorry, so you cannot create those 27, 28 lines ACLs again. Let's just put the ACL tag here and push that ACL. You can use security tags as well, voice domain permission, web redirection, asset vulnerabilities, re-authentication. There are tons of things you can do right here, right here. You can do all that from here. Let me show you that authentication profile once again. No. Okay, there we have it. Now, before we change this, the system was touching this one, permit access, and now it is touching demo profile with the SGT tags of developers. Although we have not removed that, just like the ACL, it depends on which is the top one. And here, this is above the authorization demo rule is above the default. So authorization demo rule would be have preference if over the default. If nothing matches, then let's go back to the default. Now there's one more thing I completely skimmed over, and that is this default network access. Now this is the protocols that you allow when exchanging from the supplicant to the ISE. Now these are by default allowed, MS-CHAP2, EAP, TLS, and everything like that. But the Windows workstation that we are using, this brother right here, this is a Windows 7 workstation. And 80% of, I'm not sure about rest of the world, but there are some applications in Pakistan that still require a Windows 7 workstation to run. There are some audit applications, I'm not sure which ones, but there still are some banks still require your Windows 7 to authenticate and work. For that, you will need to go way down right here and this allow weak ciphers. Now this comes in play when you have a really old workstation, like we have Windows 7 workstation with about the absolute first build that came out, because Windows 7 workstation uses TLS 1.0. Now all right here you won't find TLS 1.0 even once, not even once, not TLS 1.0. So you will need to use weak ciphers for the ETLS. And once you do that, all should be good. Now, just here, right here. Now, here you have the one endpoint. That is the endpoint that came up. Live sessions. Yep, live session right here. Helpdesk infra is right here. Workstation, security group tags, no posture. The authentication method that he is using is .1x. This is the authentication protocol that it used. The NAS IP address, and absolutely everything. Let's just have a look at this report as well. The first report is generally the authentication report, and the second report is the authorization report. Now, if something goes wrong, if absolutely something goes wrong, okay, let's just make something go wrong. Let's just make something go wrong. Now, let's just drop it, remove the weak ciphers, apply it again. Let's ask this guy to bounce report. Let's bring it up again. And now let's see here. The authentication failed. Now, why has the authentication failed? Let me just show that to you. Radius live logs are back again. Now see the red mark, the authentication failed. Why has the authentication failed? Client did not provide cipher suits. Client didn't provide cipher suits that are allowed on ISE. Here is the message that you need to be focused on. Yeah, if someone is trying to say anything, please go ahead. If you are not trying to say anything, can you please mute your mic? Someone by the name of Divine, I guess, has their mic on. Yeah, thank you.
Go. I muted him. Go.
Oh, great, thanks. So this is where your TLS handshake fails. This is what I was talking about when I was talking about TLS 1.0. The TLS 1.0 is a weak cipher that is not enabled by default. You need to enable it so that you do not have a TLS handshake failure. Now I'm going to enable the weak ciphers again. Save this guy. 1 second. Let's ask him to bounce his port again. And there you have it. User is authenticated back again. Open up, radius live logs, and voila. back to green again. Back to green again. Everything looks happy. Let's look here once again. Authentication succeeded. Makes sense. The AD join. My endpoint is a Microsoft Workstation. EAP MS Jab switches. This is an extremely detailed report. Extremely detailed. Everything that you can see here is right here. This is the workstation that has. This is the CN name of the user that we have connected. See, this is what I was talking about. The TLS version. The TLS version coming from the endpoint is a TLS1. Now, this is the UID of the group that was imported. And this is your tag that was pushed. The A22.1 tag, and that is your VLAN 25. Radius accept, everything looks happy. And with that, I will be concluding my session here. Active endpoint 1, rejected endpoint 0, everything looks happy. Anything, Ramsey, you want to talk about, or you want me to?
Thanks, man. That was very informative. I would like to say something here is, thing is here is for the new guys, guys who have never worked on ISE, this may seem like a big something new. It's like very complicated, and so that's perfectly fine, because for those of you who've never worked on ISE, you need to spend some time on ISE to be familiar with how are things going on in ISE. So it's okay to like be a little bit like confused, lost, or you might have a lot of questions. There's something that I remembered while you were presenting. You might ask me, for example, what about devices that actually like a printer or a telephone that you cannot have authentication on? You cannot have like a username on a printer or something. The concept of map that Taimur was talking about, map is actually the process of map is this. I will be like connecting my phone or my printer to the network. I will be profiling this endpoint, this printer. After I profile this printer, I can know, because I already will be configuring a policy for printers to have a certain access to my network. So that's how everything is done. Not everything is 802. Not everything requires username and password. There are things that actually it's not supported to have like username and password on a printer. So it uses MAP. MAP is the MAC authentication process. MAC authentication bypass, MAB. It's actually there for the devices such as the printers and the phones. Usually it is used in a place where you need to profile the endpoint. After profiling it, first of all, it will be like in a quiet time for some time. After successful profiling, I'll be checking my policies again. I should be like configuring a policy regarding this printer, regarding that, for example, Cisco phones, HP printers. You can do very deep. ISE has a database about everything. It's very it's very big, as I said, and that is where we can use MAP. It is like a replacement for 802.1x for devices that does not support like user authentication. In brief, this is ISE. We like strictly like we did emphasis on AAA. As I said, you have a lot to learn on ISE. For those who want to achieve the CCIE, you guys need to spend some time on ISE. There's no like, you cannot run from that. You need to spend some time, you need to learn, you need to lab everything up. ISE is a big product, and with practice you can like make it. With practice you can start like deducing how everything is working, the new concept of the VLAN pushing, the access list pushing, and everything. So for now, thank you guys. We will be like, if someone has a question, we can take it to the group, but for now I'm gonna stop the recording. And again, thank you, Taimur, for having this very nice lab. I'm sure a lot of us like learned something or two. You need to say something?
Yeah, Ramsey. Not for you, but for everyone that have just attended lab, I've pasted a link, Google form. If you could just fill it on for me and Ramsey, that would be great. Thanks.
Yeah, so that's a feedback for us.
Yeah, that's the
And
feedback.
I will be inviting you guys to like give us some sessions about things that you're good at. Okay, so thank you
Yeah.
for now, and we will be taking this to the group. Thanks, guys.
Cheers. Bye.